Okay, we are just reviewing over the commonly missed problems from the quiz yesterday. So approximating the mean of a data set when given a frequency distribution. It seems these days that students have to work more and more each week to be able to afford the cost of college. For a recent labor survey conducted by the government, there were 78 respondents who were working while attending college. The frequency distribution below summarizes the number of hours worked per week as reported by the respondents. Okay, so remember, typically with frequency distributions, they group them into intervals, right? We talked about these. So they're just telling you that there was 8 responses that were in between 26 to 30. We don't know exactly where the 8 were. They could have all 8 been at 30 hours, okay? Or they could have been obviously sporadic. There was 25 that responded in this interval. So that obviously is going to like affect our mean, okay? It tells us right here, use the midpoint of each class data to estimate the mean or the average numbers worked by each of the respondents. So because we don't know where these are located in the interval, we just use the middle, we use the midpoint. Okay, so the first thing we gotta do is calculate the midpoint of each of these. Now, a lot of these you could probably easily do in your head, like what's halfway between 26 and 30, but if they're weird numbers, this would be the math you would do. You just find the middle, find the average. All right, 31 and 35. Halfway would be 33. 36 and 40, halfway would be 38. Okay, yada, yada, yada. So 41 and 45 is obviously 43, 48, and 53. Those are all the midpoints. Okay, so it makes sense why we have to use the midpoints. We don't know, we just know the number in each interval. We don't know where, so we just use this to approximate. All right, so then when I'm calculating the mean, I don't just add up these numbers. I have to factor in how many people responded that in each of these intervals. All right, so yes, we're using the number 28 for the first interval, but how many people actually said 28? 8 of them. So you have to times that by 8, unless you want to write out 28 plus 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 28. You don't want to do that, right? Write it out 8 times. If you had 8 people that said that was on average how many hours they worked, 8 of them. Okay, then we had 25 in our next group, in our next interval. So I got to do 25 times 33. Okay, that's the midpoint of my next interval. And then 38 for the next class. Oh, no, 18 for the next class, sorry, times 38. Oof, must be a mistake. 18 times the midpoint, 38. And then 14 for the next class, which was a midpoint of 43. 8 for the next class, midpoint of 48. 5, the last class, midpoint of 53. All right, so there's all my responses. And then to calculate the average, we divide it by how many people, which they told us. You don't even have to add up the frequencies. They told us there's 78. Okay, do we need to go over how to type this stuff in our calculator, or do we feel like we know how to do that? Good. All right, if you want to try to type this one in, here's what I got. And it says to round your answer to 1 decimal place. So I got 38.3. Okay. I want to say that half of us missed that problem on the quiz, but I think only half of us got that one right. Questions? So a histogram is just basically like a visual of a frequency distribution table. It's just a bar graph of your frequency distribution. So it's the same math. It's just presented to you, the data's presented to you in a different way. Okay? So that's what we're going to do next. That was another one I think that 50% of us got correct, was just straight up finding the mean when given a histogram. So this is the same thing we just did. They're plotting all the different frequencies, but now it's just in the form of a graph, okay? So, I'm not going to read through that whole backstory there, but you tested 29 participants and recorded for each participant her experimental adjustable fixed ratio. And here's their data. So we had 4 people say their adjustable/fixed ratio was in between 0 and 0.2. 4 people in the next class. So again, we have to start by finding the midpoints because we don't exactly know where these people lie in each class. So we know there's 4 in that class, so we'll just find halfway to use as our guide. So these are obviously pretty easy. 0.1, 0.3, 0.5, 0.7, and 0.9 be the midpoints. Okay, so then when we're calculating our mean, and I'm going to do approximately because this isn't our exact mean. Like I said, we don't know exactly where they were in these intervals. So the mean is just an approximation here. And then I just got to figure out my number of people in each class. There's 4 that answered in that interval with using the midpoint of 0.1. Okay, then there was 4 in that next class using the midpoint of 0.3. And then there was 9 using the midpoint of 0.5. In that class, 7 using the midpoint of 0.7. 5 using the midpoint of 0.9. Divided by how many?
20.
Yep, 29. Okay. I got 0.5. This one said 2 decimal places. 3. Make sure you're reading to what they want you to round to. Please don't think. So since we have to find the mean in the process of standard deviation, obviously if you're getting those problems wrong, you're probably getting the standard deviation ones wrong too. Also, I didn't know that Alex gave you guys the formulas. Did you guys want to set? Please click here for a list of formulas. Did you see that? I didn't know that. It's fine with me. I didn't know that. Okay, let's look at one of these. Because these can be kind of confusing, especially when it looks, it's pretty similar. So I thought this one was like kind of a good one that looks a little bit more challenging than the one we did in our notes. So you have these 3 distributions, A, B, and C, and below are their histograms. Each distribution is symmetrical and is made up of 10 measurements. So we want to order their respective standard deviations. Okay, so this goes back to like understanding what standard deviation is. It's the average distance away from the mean. So as the entries get further away from the mean, the standard deviation gets bigger, gets larger. All right, so if it helps you to like draw in, well, I know you obviously can't on Alex, but it helps you can kind of draw in where the mean is. And in Alex, they always have you like write these as a, what type of a compound inequality is what I'm trying to think of. Yeah, compound inequality. So right away, just looking like around the mean, do you see how in A and in B, they both have like 2 blocks like pushed very, very close to the mean? So that's in relation to this one, C. That's pretty close to the mean. All right, and then looking at C, you're like, well, look at these. I have like 3 blocks like way out here. So the average distance away from the mean is going to be larger. Okay, which means your standard deviation will be larger. So C definitely has the largest standard deviation. So that one you put here, and I'll kind of explain the compound inequality once we get it set up. But that one's definitely like the furthest from the mean. It's not necessarily, I think maybe the way you were thinking is like it's like spread out, which is also kind of true, but technically standard deviation is calculating the average distance away from the mean. So even though this isn't super spread out, it's further away from the mean. All right, and then I got to compare these two. So now their differences are they both have like 2 blocks grouped around the mean. This one has 3 blocks way out here, and this one only has 2. So technically, this one is farther away from the mean than B. Does that make sense? Because it has all 3 of these blocks located at like 3 and 11. So in comparison, this one's farther. So that one's going to have a greater standard deviation. And this one's going to have the smallest standard deviation because technically it's the closest to the mean. Okay, now if you don't understand this, this is basically just saying that the green is greater than the blue, but still less than the red. And the red's greater than both of them, and the blue's less than both of those. However you, I don't know, want to interpret that, but the further away from the mean, the bigger the standard deviation, bigger the average distance, because that's what standard deviation is. We can write that down if you want. Standard deviation is the average distance from mean. Okay. Ooh, next we're going to go over the symbols. Let's see if you guys got these down. I think this one it wasn't 50% more if you guys got this one right, but there was still like, I think maybe like 33% or something. Like a third of us got this right. That's the nice thing about those tests on ALEKS is I can clearly see like the commonly missed problems and all that good stuff. All right, so I know some of these, I just stole this chart from the textbook that we use, but some of these I know aren't on ALEKS. Like I think the main ones are like the mean and the standard deviation. I think that actually might be it. So let's go over those first. So mean, when given a population, that one's the mu. And a sample is the X bar. Anyone have a good way that they remember those? I don't have like a fun trick like something to
No, but I did notice how it's written the different on ALEKS. Like,
is it?
Well, it's kind of like that. I don't know. It's like something weird, kind of. I don't know. It just looked different than. I don't know. I don't know if it's a big U, but it was like.
It just looks a little different.
I guess from how I drew it.
Okay. I wonder if it's too. I mean, it's probably when you like type it, it looks maybe just a little different.
I mean, I got it. I just didn't.
Okay. Okay, standard deviation for population is the one with like that looks like a little like hat. And for a sample, that's S. That one's pretty easy to remember because sample starts with S. So to finish filling this chart, we can. The variance is the standard deviation squared. Normally we think of it as just standard deviation is the square root of the variance, but that's the same relationship. Number of entries, we typically use a capital N for a population, lowercase n for a sample. Deviation is like the distance away from the mean, the data entry. So here's your data entry minus how far it is away from the mean. That's what deviation is. There's no like questions that straight up ask you for your deviation. It's just used in the calculation of standard deviation, obviously. All right, so then this one is same thing, but using the correct notation for mean. Sum of squares is again like a process we use when calculating the standard deviation. So we use that sigma. I guess I don't even really use the sigma, but we take that deviation and we square it. Okay. So there's a review on the symbols, and now we're ready to calculate the standard deviation. Maybe what I could do, this might be fun, like create an individual assignment just for you of the ones you got wrong on your quiz. I should do that instead of making you guys do all the same problems, like ones you already got right. Unless you want the extra practice. It could be like, you tell me what you want to practice. Oh my gosh, how fun. All right, so I did one of each. Population standard deviation and a sample standard deviation because they are different. And you do get the formulas on your test so you can kind of see if you need to subtract one or not on the formula. But the population, that's the one where you don't need to divide by n minus 1. You just divide by the number of entries. Okay, so the reason why I know this is a population is it'll say that, or it'll say of this sample. So it says, in a particular hospital, 5 newborn babies were delivered yesterday, and here are their weights in ounces. Assume that these weights constitute an entire population because that was all 5 of the babies that were delivered yesterday. So that's the whole population. Find the standard deviation. Okay, first step, find the mean. If I want to calculate the standard deviation, if I need to find on average how far are these weights away from the mean, I got to know what the mean is first. Okay, I'm going to even use the correct notation here. So it'd be mu when we're talking about population. Here, I would just add them up. And divide by 5. So I got 107 for the mean. Okay. And then I basically, from there, find my variance. And then I just square root that to find my standard deviation. Okay, so your variance, you can write down this notation if you want, but is you have to start with figuring out, like, okay, where is each data set? How far is it, or does it deviate away from my mean? So I take my data entries, 93, and I subtract the mean. That tells me how far it is away from the mean. And then what I have to do is I have to square that. Okay, and this just helps us like calculate the average with the standard deviation. Now, I have to do that for every single data entry. So I'm going to do that for 103 as well. How far does that deviate from 107? And I know if you can do that math in your head, you don't have to write it out like this if you don't want to. I just honestly am kind of better at just punching it all in my calculator at once. So that's what I like to do. And you do have to add up all these numbers together. Okay, that's what the sum of squares means. So the sum of squares, this helps us calculate the standard deviation. So then my next data entry is 129. How far does that deviate from the mean? Square that. Last one. Oh, just kidding. I gotta do 108 and 102. Eight and 102. Oh yeah. Well, I'll talk about that later. Okay. So to find the average, we divide it by the number in our population, which is 5. And so what I do, or how I kind of showed you, is I type this all in at once with the parentheses, with the exponents. And so for that, I got 722 over, and then obviously still over 5. So then after you calculate that, you can find the standard deviation. The standard deviation is just the square root of the variance. So then you just square root that fraction. Everybody okay with typing square roots and fractions in our calculator?
Yes. Okay.
This one says round to 2 decimal places. So if you want to try and punch that in, please do so to get the practice. I got 12.02. And then obviously see if your answer kind of makes sense. See how spread out the data is. and you know what the mean is. So the mean is 107. So if I listed these in order, the mean is right here. So you can kind of like think, all right, how far away am I from the mean? Does it make sense that average it's about 12 spots away from the mean? Because 12 spots this way would be like 119. So that kind of makes sense. I have a big one here. Just kind of like that, I guess. See if it makes sense. Okay. Any questions on that? It's a very step-by-step procedural type of problem. I actually like this stuff because it's more mathy. Okay, so again, if I want to calculate it in a sample, this is different. This is different, and the only thing that's different is when I find the variance, I just have to subtract 1 from my number of entries. And the reason why is because it just creates like a little bit of bias, or it eliminates bias. But when I'm finding the mean, I still find the mean the same way. I don't subtract 1 from that, okay? So here it tells me shopping times for a sample of 6 shoppers at a particular clothing store. Find the standard deviation of the sample. Okay, so I'm still going to start finding the mean. Again, that part doesn't change, so this one's X bar for a sample. I'd still just add these all up. And divide it by 6. So I got 36. Then we find the variance. All right, so same steps. Start with each data entry. Figure out how far away it is from the mean. So 37 minus 36, that's obviously 1. And like I said, you can write it as 1 if you want to. Square that. Plus, next one, 43. How far does that deviate from the mean? I found this like cool like video too that like explains like why we square them and why we sum them together. It like gave you this like nice visual off like a, I don't know if it was a histogram. I don't think it was a histogram. Some type of graph. I can't remember exactly what it was, but okay. And I do the same for all those. All right. 35 minus. Last one is 39. Anybody add those numerators together yet? What'd you get? 238. Yep, that's what I got too. All right, now here's the way I remember with the sample. Is we have to take this divided by our number minus 1. So we actually have to divide this by 5. So again, that's only in the variance part, not when we're calculating the mean. So then I can find the standard deviation. By square rooting the variance. Okay, what is this one? Rounded 2 decimal places. I got about 6.9. All right, last one. Histogram. So, approximating the standard deviation when given a histogram. And then we'll be done with this, and I'll let you guys practice. Okay. So, same steps. We still have to find the mean, find the variance. So, obviously what I was saying before, if we struggled with finding the mean of just a straight up histogram, chances of getting this one correct are pretty slim. So personality test, it looks like, and they were scored on a scale of 0 to 200. So suppose that a group of 60 classmates has taken this test and their scores are summarized below. All right, we still want to find the standard deviation. So again, the tricky things with histograms or frequency distributions is we don't exactly know where the data is. We're just given classes or intervals, and we know how many people responded within that interval. So we will have to calculate the midpoints. These ones are easy to calculate. So we got 20, 60, 100, 140, and 180 are the midpoints. So I'm looking here and I'm like, was this a sample or population? And it says sample. So that'd be my X bar. All right. So just like we were saying, we do have to use the midpoints. But we also have to factor in how many people responded in each class. So I would have to do 10 times 20 plus 10 times 60 plus 15 times 100 plus 20 times 140 plus 5 times 180. All over 60. I got a mean of 100. All right, here's another kind of tricky part when we're finding the variance. We again have to factor in how many people responded in each class. Oops, I think I used the wrong notation on the last one. I think I used this instead of S for sample. Dang it. Sorry. You can change it if you want. It should be S for sample. Okay. So I still have to calculate like how far away from the mean each midpoint is. So I would still do my 20 minus 100 squared. But I have to times this by how many people were in that class. So again, I have to times this by 10. Okay, because there was 10 people that had that deviation away from the mean. There were another 10 people that had the deviation of 60 minus 100 squared away from the mean. Next class, there's 15. That were right on the mean. So it's obviously just going to be 0. There were 26 that were in the 140 class. And then there were 5 in the last class. All right. Because this is a sample, I do need to subtract 1 for my number of entries. Good. So I just left this I got it as a decimal. I could have done it over 59. Did you get that number over 59? It looked like you did.
Yeah.
What is it?
144.
Over 59?
Yeah.
Did you get like this decimal?
Yeah. 27.
Yeah. That decimal. Okay, beautiful. So to find the standard deviation, just square root that. All right. Sorry, being sloppy. I got about 49.4. So I'd round to at least 1. Okie-doke. Questions? Make a little bit more sense seeing a couple more examples. Oh, I remember to do the rate notation in this one in my notes. Okay. I think I like the idea of creating an individual assignment. You guys like that?